All right, guys, example 1 says, apply the first two definition of a derivative to the function f of x equals x squared plus 3x. So we are going to get to try both derivative definitions. So here's the formal definition. The formal definition, student, says f prime of x is limit as h approaches 0 of f of x plus h minus f of x all over h. Ready? We are going to do the other one on this side. The alternative definition is f prime of x equals the limit as our given point. Okay, so as x approaches a, so x is a nearby point, we want it to get really, really close to the given point of f of x minus f of a all over x minus a. All right, let's work this out. Ready? Get set, go. All right, f prime of x equals the limit as h approaches 0. We're just going to focus on this side first. We do want to calculate f of x plus h. As you guys know, every time we see an x, we do want to input in x plus h, okay? So we have two locations of x's over here. So one is the square. Whoa, oh my goodness, every time I pinch it in, it does that. Okay. So one is going to be something square, and then plus 3 times something. Now minus f of x, okay? Minus f of x, meaning that, hey, f of x is given to you already. F of x was given to you as x squared plus 3x. So we want to minus the entire f of x. So that's x squared plus 3x. So that is f of x right there. So for f of, this is the part where I feel like some of you are still struggling. Whenever you guys are evaluating f of x plus h, if you see an x in the original, you're going to put in x plus h. If there are multiple x locations, you put it in for every time that you see an x in the original, okay? Then just from there, slowly FOIL that out. So the limit as h approaches 0, FOIL the first quantity, that's going to be x squared plus 2xh plus h squared. Then distribute your 3x here plus 3h, distribute the minus sign, so minus x squared minus 3x all over, whoops, all over h on the top as well. My bad, guys. Okay, then from here, see if we can cancel anything out. Ready? We can cancel one of those, and now we will try to factor out the h from the numerator. So we are going to end up with 2x plus 1h here, then just plus a 3 all over h. Those two will cancel. Remember, h is approaching 0. So by substitution, I'm going to write this down. Okay, so by substitution, 0, we have 2x plus 3. So students, when it's all said and done, f prime of x is plus 3. Okay, so this is the derivative of our original equation of x squared plus 3x. Remember, the derivative is the slope. So this equation represents the slope of all given values of x, okay? Now we are going to try to use the second formula here to see what's going to happen. We are going to, remember, we don't know, we're not giving an a value, so we're going to assume an a value will still be an a value. So x approaches a, f of x, students, is this original equation, so that's going to be x squared plus 3x minus, to evaluate f of a, every time you see an x, we are now going to do a squared plus 3a all over x minus a. Then from here, we are going to slowly work out the algebra. So x squared plus 3x minus a squared minus 3a all over x minus a. Here is when we are going to use some algebra manipulation. And you know, math is amazing. Okay, here we go. X squared, I'm going to regroup the square term together. And I'm going to write the 3x and the 3a together. After that, we are going to try to factor out these two and factor those out. So factor by grouping, okay? So the limit as x approaches a. So the first two groups, guys, that's a difference of two squares, okay? So we're going to go, okay, difference of two square, x plus a times x minus a. The second two group, we can take out a 3 because that's the GCF. We now have x minus a left, all over again, x minus a. Now, as you can see here, we can cancel this and this and this because technically, if you want to see another step here, we'll do another step here. Technically, from there, we can factor out x minus a because they have that in common. Then we are ending up with an x plus a plus 3, okay, all over x minus a. So if you want to wait until here to cancel, that's okay too. But as you can see, now it says if x is approaching a, okay, again, if x is approaching a, and by substitution, right, every time we see, if let's pretend that this is a value of 5. So if x is approaching 5, every time we see our x, we need to plug in 5. But we don't know what a is since it didn't really give it to us. So every time we see our x, we will plug in an a. So a plus 3 all over 1, which is no longer there. So students, this is 2a plus 3. Now this is when we have x equals to a, okay? So the derivative, so f prime of x is 2a plus 3.